In this lesson, we talk about the differences between these two things called relations and functions. And you don't really do too much with relations and functions in Algebra 1. Most of the stuff that you'll do with functions will be in Algebra 2. But we start using the terminology and the phrasing and the notation for functions now, so that way when you get to Algebra 2 and pre-calculus and trigonometry and all those other advanced math classes, you already have some of the foundational work done for functions. A relation is a less specific type of function. A relation just simply pairs inputs with outputs. And a relation in which each input has exactly one output, that's the key important point, exactly one output, is called a function. So in a relation, you can have an input creating more than one output, and you'll see in an example what that looks like. But in a function, it's one input, one output, and that's it. So let's look at some examples and determine whether we're looking at relations or functions. In example A, we first look at our inputs. -2 is an input right here because it's an x value, it's in the domain. Are there other y values paired up with -2 other than this pair here? So -2 pairs with 2. Does it pair with anybody else? No, so -2 is fine. What about -1? Does -1 pair up with anybody other than 2? No. What about 0? Does 0 pair up with any other numbers other than 2? No. What about 1? No. And here, you might say 2 pairs up with 0 again, but be careful because here 2 is an input domain value, and here 2 is a range value. So since each input only has one specific output, then this is a function. Let's check out letter B. Letter B, I'm going to explain in a second. It is not a function. So let's look at -2. Does -2 pair up with anybody other than 3? No. -1 only pairs up with 4. But you see right here, 0 pairs up with 5, but it also pairs up with 6. If I tell you my input is -2, you know automatically what the output is. If I say the input is -1, you know exactly what the output is going to be. It's going to be 4. But if I say I'm going to input 0, you have two possible correct answers. You could say 5 and you'd be correct, but you could also say 6 and you'd be correct as well. Whenever that's the case, what's going on right here happens. Whenever that happens, then you are not a function because you have this kind of uncertainty about what output value you're supposed to use. What about letter C? -9 only pairs up with 0, -2 only pairs up with 5, 5 only pairs up with 10, and 12 only pairs up with 10 as well. It's okay to repeat in the output. This might be something you want to highlight or annotate. It's okay to repeat in the output. It's really the input that matters. As long as 5 only goes to one number and 12 only goes to one number, this is still safe as a function. Because again, there's no uncertainty about what number is the output. If I say the input is 5, you are certain that the output is 10. If I say the input is 12, you're certain that the output is 10 again. But there's no uncertainty about what the output is going to be. There's this super cool thing that you'll do when you get to Algebra 2, like I said, or pre-calculus or calculus. You could use this thing called the vertical line test to help you determine if something is a function. And this only works if you have a picture, but you will frequently have lots of pictures in upper level math. So the way the vertical line test works is that if you have your picture, so here's a discrete graph, here's a continuous, and you draw a bunch of vertical lines down through the graph. So they just have one example right here, but you can draw vertical lines through all of the points. And as long as each vertical line only hits one point on the graph, then that's why this one is considered a function. Since the vertical line here hits 2 points on the graph, then this is not a function. And so if you fail the vertical line test, you're not a function. If you pass the vertical line test, you are a function. Each vertical line only touches the graph once, whereas here, the vertical line hits it twice. So if you fail it even in one spot, you fail the test completely. Because right here, if I draw a vertical line down here, you can say, well, it only hits once here. But it failed the test over here, so that's why it fails the test completely. So let's check out vertical line test in example 2. If you draw vertical lines through the points of the grid, oh, whoops, my vertical line hit both of these points. So it doesn't matter what happens in the other spots. I found a place where it fails the test, and so this is not a function. If I draw vertical lines through this graph, there's never any spot where it hits more than once, right? These are all spots where it's hitting, but it's only hitting once. And so this is a function. If you have any questions, write them down and ask me when you come to class.